Assalamualaikum warahmatullahi wabarakatuh. Selamat datang ke program Lepton dan Meka Sesi 2020-2021 Anjuran Unit Fizik MM. Sesi kita adalah sesi yang keempat bagi kali ini, dan pada sesi ini kita akan mempelajari chapter kelima untuk semester 1, iaitu Work, Energy and Power. Sebelum saya memperkenalkan pensyarah pembimbing kamu semua, saya ingin memperingatkan bahawa link borang kehadiran akan diberikan di penghujung program pada hari ini. Untuk kehadiran kamu direkodkan, sila ingat untuk mengisi borang tersebut. Okey, untuk sesi kali ini, pensyarah yang sangat berpengalaman dan berwibawa akan membimbing kamu semua dalam menjawab soalan-soalan yang berkenaan dengan chapter 5. Mereka ialah Cik Hanisah binti Samhun dan juga Puan Salmah binti Uthman. Kita semua mengharapkan bahawa semua pelajar boleh memberikan penglibatan yang sangat aktif dan memberikan fokus dalam menjawab semua soalan yang akan dibincangkan. Selamat belajar!
Assalamualaikum. I am Madam Salmah binti Uthman. For today's program Leptons and Meka, I'm going to discuss chapter 5, Work, Energy and Power. To begin this discussion, let's review the list of equations that we found in this chapter. Number 1 is work. Formula of work, W equals to Fs cos theta. Second, W equals to area under force displacement graph. Next, number 2 is conservation of energy. Summation of initial equals summation of E final. MGHI means potential energy plus half mu squared. Initial kinetic energy plus half kx initial squared. Initial elastic potential energy equals mgh final potential energy, but for final plus half mv squared. Final kinetic energy plus half kx final squared. Final elastic potential energy. So number 3 is about work energy theorem. It states that work net equals to delta T. Work done by net force equals to the change in kinetic energy. So the formula is F net as cos theta equals half mv squared minus half mu squared. Number 4. Number 4 is about power. So we start from average power. So formula is given by delta W over delta T equals Fs cos theta over T equals to delta U over delta T equals to delta U here means mg in bracket h final minus h initial over T, or delta K over delta T equals to half m v squared minus u squared over T. And lastly, instantaneous power is given by Fv cos theta. The first question that we will discuss today is question number 3 from PSPM 2012-2013. But if you have physics extra question, you can refer to question number 17. 3A1. State the work energy theorem. This theorem states that work done by net force equals to the change in kinetic energy. If we expand this theorem, you will get work done by net force is F net as cos theta equals, the change in kinetic energy here means half mv squared minus half mu squared. Alright, look at number 2. A 0.5 kilogram box is initially at rest on a smooth horizontal surface. It is acted upon by a horizontal force for a distance 3 meters. If the speed of the box is 5 meters per second, calculate the magnitude of the force. Let's figure out this question by sketching a diagram. Let's say this one is a box. The box is placed on a horizontal surface. Since the surface is smooth, so no friction force. Or Fk equals 0. And then over here there is a horizontal force I label as F. And we want to find out this F. So I just put question mark here. Alright, due to this force, this box displays by 3 meters away from the initial position. And the speed over here is 5 meters per second. Alright, so what is the initial speed? U equals 0. How do we know? Stated here at rest. So U equal to 0. And then the mass here is 0.5 kg. Alright, next. Here to solve this problem, we have to apply work energy theorem. Why we have to apply this work energy theorem? Because the first question asks about this theorem. So the next question we have to apply the theorem. So we write again this theorem. F net S cos theta equals half mv squared minus half mu squared. F net. So what is F net? Refer to the diagram here, only F is applied on this box, no friction force. So the net force here only due to this applied force. So you just write F. S 3 meters cos theta. What is theta? Theta is the angle between F net and S. Over here, F net means this force, this is S. The angle between direction of F and S, theta equal to 0. Same direction. So you just put here theta as 0 equals half m 0.5 v 5 meters squared minus half 0.5 u is 0. Since you know u here is 0, so you can put it at 0. Alright, so by using this, we solve what we get. We will get F equals to 2.08 Newton. We get it. Same as suggested answer. Okay, next, I'm going to discuss question PSPM 2018-2019, question number 5A. Alright, so here you are given graph F against S. As you know, if you are given graph, from this graph, you can calculate area. So area under FS graph gave work done. Alright, so look at the question. An object of mass 2 kilograms, m equals to 2 kilograms, travels along horizontal floor under the action of force F. Figure 5.1 shows the graph of F against displacement S. The speed of the object at S equal to 0 is 10 meters per second. So this one would become U, initial velocity. At S equal to 0, over here, U equals 10 meters per second. Determine the speed of the object at S equals 10 meters. Alright, over here, S equals to 10 meters. Okay, the value of V is, we don't know, because we want to find out. Alright, so in this case, since you are given graph, from the graph, we can calculate area under the graph. And over here, you are given the initial velocity, find out final velocity. So here we are going to use work energy theorem. So work energy theorem states that W net equals delta K. W net means F net as cos theta equals half mv squared minus half mu squared. But in this case, the work done by net force is given by area under the graph. So here means area under graph, under Fs graph. So what's next? Or let's we find out the area under the graph. Okay, we divide into a few portions here. So let's say this one as portion A, this triangle as B, and this small triangle C, and this one become D. Okay, alright, let we calculate the area under graph for each portion. For A, what is the area under the graph? A equals 4 times 10. So we'll get 40. Okay, so here we calculate work. So even though the unit is F over S, means Newton per meter, and Newton meter here, because you just multiply. But here, since this is work, so you write as 40 joules. Okay, alright, next. The next portion is B. So B equals the area under graph for portion B. Half 6 minus 4, you get 2. And then this one is 10. So cancel out 1, this one becomes 10. So the answer is 10 joules for portion B. Okay, next. For portion C. C, area under the graph for C. Okay, also triangle, half. 6 minus 7, you get 1. And then over here, you get negative 5. So negative 5 over 2, you get negative 2.5 joules. Alright, lastly, D. So for portion D, the area under the graph is 10 minus 7, you get 3. 3 times negative 5. So you get negative 15 joules. Okay, let's find out total area under the graph. So area under the graph, equals A plus B plus C plus D equals, okay, what is area under the graph for A? 40 joules. 40 plus B is 10, okay, plus C is negative 2.5, plus D is negative 15. So calculate, we get the total as, okay, use your calculator, what will you get? Alright, so you get 32.5 joules. Alright, so we will substitute this area into this equation. Let me label this equation as equation 1. So from 1, From 1, substitute area under the graph into this equation, so you get 32.5 equals half. Okay, you just substitute all the values here that we know. M is mass is 2 kilograms. Okay, V is final speed here. You want to find out this V final minus half M2, and then U here is initial speed given as 10. So this one 10 squared. So over here you write again. So this one we can cancel out, get 1 equals to V squared minus. So this one you get 100. So from here, V squared equals to 132.5. So you get V. Calculate V, you will get V equals 11.51 meter per second. For question 5b, an object of mass 2 kilograms, M equals to 2 kilograms, is placed 30 centimeters directly above the top end of a vertical spring, as shown in figure 5.2. The spring constant K equals 2000 Newton per meter. Calculate the speed of the object just before striking the spring. Next, determine the maximum compression X. So in this case, firstly, I suggest to you we sketch the diagram. Okay. Firstly, the position of the object at a certain height. The height here is 30 centimeters. We write as 0.3 meters, convert to meters. After that, what happened to this object? The object moved downward. Now, the next position here is over here. But the spring does not compress yet, but very close to the upper or the top end of the spring. So, this question number 1, we want to find out this speed. So, I put question mark here. Okay, next, what happened? The block will compress the spring. Now, the spring is being compressed. By how much? I label here as X. That is the maximum compression. Next, label the position. Here as point A, this one as point B, here as point C. Okay, before we go further, we list down all the mechanical energy that we have learned. So, gravitational potential energy given by mgh. Next, we have elastic potential energy, half kx squared. Next, kinetic energy, formula half mv squared. Alright, to know in the system whether there is potential energy, elastic potential energy, or kinetic energy, we refer to a certain quantities. For example here, if there is no H, focus here, when there is H, there is potential energy. The next is elastic potential energy. If there is X, there is potential energy. And when there is velocity here, V, there is kinetic energy. Okay, so we have to check whether there is H, X, or V at each point. Okay, alright, so at point A, so I just write here H, X, and V. Okay, at this point, is there any H? Yes, 0.3. So there is potential energy. Next, X. X refers to the compression. Is there any compression? No. So this one, 0. Next, at this point, normally at this point, at the highest point, V is 0. So at this point, only has potential energy, meaning that mgh. Next, at point B, okay, again, we write H, X, and V. Okay, so to know H here, height, we have to consider the reference level. Where we take the reference level. So if, for example, here, I have to draw a line, horizontal line, to join between point A, position A and position B. I compare this one, I draw this line, horizontal line. So I take this line as reference level. So to measure height, we take from this point to the position of the object. So point A, H is from this point or this line to the object. So that's why it's 0.3. But over here, is there any H? No. H is 0. Next, X. X is compression. No compression. So this one, 0. Okay, next, V. Yes, we want to find out V. Alright, so at point B, the energy is only kinetic energy. Alright, so now we have to write the principle of conservation of energy. That is, summation of E initial equals summation of E final. Initial here means point A, final means point B. Okay, we write again this principle as summation of E at point A equals summation of E at point B. At point A, only mgh. At point B, only kinetic energy, half mv squared. So from here, since both terms we have m, we can cancel out by dividing by m. And then from here, you can get the value of V. So V equals to 2gh. Okay, everybody calculate what is the value for V. Use your calculator. 2 times 9.81 times H. H is 0.3. So after you calculate what you get 2.43 meter per second. So the answer here is V equals to 2.43 meter per second. Next, for question number 2. This one should be written as 1. Question number 2. So for question number 2, see, for question number 1, we apply the principle of conservation of energy. So for question number 2 also, we will apply the same principle. But here, we want to find out what is the maximum compression. Okay, for maximum compression, V equals to 0. Because at maximum point, the object will stop. When it stops, V is 0. Okay, so at this point, again, we have to write H, X, V here at point C. Okay, again, H, X, and V. Okay, V here is 0. We have discussed just now. So this one is 0. Okay, and then there is X. Yes, because the spring compressed. How about H? We have to measure height. Height is measured from below to the object. Okay, so here we have to choose the reference level. So the reference level now we take as here, just below this object. This is the reference level for this situation, for this example, for this case. Right? Okay, now, so now can you see I write here X? Okay, here also X. Okay, now, next is we have to compare two positions. Which point become initial and final? Okay, since we want to know X, so I suggest to you, we compare between point A and point C. If you want to compare between point B and C, also can. But here, I prefer to compare energy at point A and point C. So, for question number 2, we apply the same principle. Summation of E at point A equals summation of E at point C. Okay, at point A. Okay, at point A, there is elastic potential energy. But now, what is the value of H? The value of H is, start from here. We measure H from this level. So H now become X plus 0.3. Okay, alright. So you will write here mg H. H is H. The height here is H plus X equals. Alright. So at this point. Okay, at this point. Okay, what is H now? What is H? H is from the reference level to the object. Can you see? No gap at all. So meaning that H is 0. So over here only for elastic potential energy. So you write here half kx squared. Alright, so we substitute all the values that we know because we want to know what is x. M. Okay, maybe we can expand first this equation. mgh plus mgx equals half kx squared. Okay, we substitute all the values that we know. M is 2. 2 times 9.81. H is 0.3 plus M2G 9.81. Okay, X we don't know yet. Okay, equals 1 over 2, 2000. Okay, it's 2000 and then X squared. Okay, so you calculate this part, what you get, this one become 5.886. And then this one become 19.62x equals, this one become 1000 x squared. Okay, now we have quadratic equation. So you have to use calculator to get the value of x. So there must be two answers for x. Okay, use your calculator now. Calculate x. So I write again the equation in a common form. 1000x squared minus 19.62 x minus 5.886 equal to 0. Okay, so by using calculator, what you get? There are two values here. First value as 0.087 meters. And second answer, we get negative value. 0.068 meters. So in this case, we have to choose the positive values. Okay, because x is distant. Okay, for this case. Alright, so this one, x, the answer is 0.088 0.87 meter. Question PSPM 2019-2020. Step number 5. Okay, figure 5 shows a 15 kilograms, so M equals to 15 kg, being pulled by a 100 Newton force. So this is F, 100 Newtons, at an initial speed. So here is U. This is U. U equals 2 meters per second. Up an inclined plane, the block travels a distance of 6.2 meters, means S equals to 6.2 meters. Parallel to inclined plane, the coefficient of kinetic friction, here is mu K, equals 0.14. By using work energy theorem, calculate the change in kinetic energy. So we have to find out delta K. Alright, so to answer this question, I suggest to you we sketch free body diagram. Then I draw the inclined plane. The inclined plane including the theta. Theta is 25 degrees. Okay, over here is the object. So you just put a point here. So the force downward, W. And then over here, normal force. And then there is force here, up the inclined plane, parallel to the surface, means along this surface. This is F. And then opposite direction, there is friction force, Fk. And then what should we do? So resolve W here into X component and Y. Sorry, this one is along Y component. So theta here 35 degree equals to this angle. So this one become WY. Okay, and then resolve into X component. This one label as WX. Diagram, we list down or we calculate all the value of forces acting on this block. Okay, we start with F. F equals to 100 newtons. Next, WY. WY equals to W cos 25. W equals to mg. So mg cos 25. So m is 15. So 15 times 9.81 cos 25. Use your calculator. You will get W y here as 133.36 Newton. Next, we calculate Wx. Wx equals to W sine 25 degrees. So W equals to mg sine 25 degrees. So substitute all the values. M as 15, G as 9.81, sine 25 degrees. So after we calculate, we will get 62.19 Newton. Okay, next, last one, Fk. So Fk equals, formula Fk, do you remember? Fk equals to mu k n. But what is n? N equals to wy. So you write again mu k wy. Mu k, the value of mu k is 0.14. 0.14. Wy is 133.36. So we calculate, we will get Fk as 18.67 Newton. Alright, next. Now, stated here, by using the work energy theorem, calculate the change in the kinetic energy. So we write the theorem. W net equals delta K. We want delta K, so I put delta K as subject matter. So delta K equals W net. So what is W net? W net is equal to work done by net force, meaning that F net as cos theta. Okay, so what is F net? Look at this diagram. So F net here is up the incline. This is F net. This is F net. Okay, so to calculate F net here equals to summation of Fx. How to get Fx? F minus Wx minus Fk. So we write here F minus Wx minus Fk. Since we have calculated all these values, you just substitute into this equation. F as 100, F is given, Wx 62.19 minus Fk, Fk is 18.67. So you get F net as 19.114 Newton. Okay, after that, substitute F net into this formula. So F net here is 19.14 S. What is S? S is 6.2. Okay, cos theta. So what is the theta? Theta is the angle between F net and S. F net up the incline. S also up the incline. They are in the same direction. So theta is 0. So cos 0. So you calculate this one. So you get delta K as 118.67 joules. So that is the answer for this question. Alright, question 5b. It would be the last question we will discuss today. It's 120 kilogram motorcycle. M equals to 120 kilograms. Accelerates uniformly from rest. Rest means U equal to 0. To 20 meter per second. V equals to 25 meter per second. In 5 seconds. The time taken is 5 seconds. Calculate the instantaneous power of the motorcycle at time 3 t equals to 3 seconds. Alright, so to answer this one, I strongly suggest to you, we sketch the diagram. So here is the motorcycle. Okay, initially at rest. And then it accelerates when there is acceleration to the right. And V over here is 25 meters per second. And the time taken to reach this velocity is 5 seconds. So if you are given U, V and T, so better we calculate what is A. So to calculate A, we can use linear motion. The equation for linear motion. The formula is V equals to U plus AT. Find A. So A equals V minus U over T. 25 minus U is 0 divided by T. T is 5 seconds. So you get 5 meter per second squared. This is A, acceleration. Alright, next. We want to calculate the instantaneous power. So the formula for instantaneous power is given by F V cos theta. So theta here is the angle between V and F. Okay. But the velocity here is the velocity at T 3 seconds. So we have to find out V at 3 seconds. So since we know the acceleration is 5 meters per second squared, so what is V at 3 seconds? So again, we can apply this formula. Use linear motion equation. When t equals to 3 seconds, what would be the value of V? U is still 0 plus A, what we get from here, 5, and T is 3. So we get 15 meters per second. Alright, now to calculate power. So again, calculate power, we use formula. I write again the formula F V cos theta. What is F? F equals to MA. V cos theta. M is the mass. The mass is 120. Acceleration is 5 meters per second squared. I just put 5. And V, this V is V at 3 seconds. 15 cos theta. Theta is the angle between between F and V. F in this case, same direction as A to the right, because F equals to MA. Direction of F, same direction as A. Since direction of A to the right, F also to the right. So direction of F, same direction as V. So theta is 0. So you calculate this one, you will get 9,000 watt. Or you can write this value as 9 kilowatt. That is the instantaneous power. Right, that's all for today. So I will end my session by saying this. Stay safe, stay healthy, stay at home. Good luck for PSPM. Thank you for watching. Hopefully it was helpful.
Assalamualaikum warahmatullahi wabarakatuh dan selamat sejahtera to all of you. Okay, tadi Madam Salma dah briefing about chapter 5, work, energy and power, dan beliau juga dah bincang a few questions about work and also energy. Okay, jadi saya continue for the power. Okay, saya pun ambil soalan past year juga, tapi ini daripada UPS. Okay, jadi ini UPS 2005-2006 dan ini ada dalam buku Facts Q yang awak beli. Okay, question number 6. Okay, kita tengok soalan dulu. Okay. A car of mass 2.1 times 10 to the power of 3 kg travel with an initial speed of 15.0 meter per second. If it accelerates at a rate of 2.5 meter per second square for 10 seconds,
Okay, calculate the change in kinetic energy and the power of the car. So we have 2 questions untuk diselesaikan. Okay, so saya bahagikan dahulu. Okay. Alright. Nak lukis pun boleh. Okay, kalau nak lukis pun boleh. Just a simple diagram. Okay, you have a car. Okay, awak ada kereta. And you ada initial speed. Okay, you ada initial speed. Right, and final speed. So, dekat sini, dia reach dia punya final speed. Okay, and within time interval dia daripada sini sampai sini adalah 10 seconds. Okay, jadi ini dia punya diagram. Next, kita keluarkanlah, kita list out all the information given. So, mass of the car is 2.1 times 10 the power of 3 kg. And initial speed of the car adalah 15.0 meter per second. Okay, lepas tu kita ada acceleration sebab dia cakap car tu accelerates. So acceleration U adalah 2.5 meter per second square. Okay, with the time interval dia 10 second. Okay, dan soalan yang pertama, dia minta kita cari change of kinetic energy, which is delta K. Okay, delta K. So, nak cari delta K, as usual, kita tahu perubahan. Bila perubahan, mesti final minus initial. So, K final minus with K initial. Okay, so K final kita adalah 1. Kita convert into equation. 1 over 2 mv square minus with 1 over 2 mu square. Okay, then kita check. Ada tak value-value dia? Okay, mass of car. Okay, ada. So, tak ada masalah. And, V ni kita tak ada. Okay, final ni kita tak ada. Final tak ada. Alright. And you punya initial speed ada. Okay, jadi sekarang ni, you kena cari pula value final speed. Okay. And kita nampak, you punya car tu travel in linear motion. Jadi kita boleh guna equation of linear, which is V equal to U plus AT. Okay, kita boleh guna yang ini. Sebab semua information ada. And awak punya U adalah 15.0 plus with acceleration kita adalah 2.5 times with 10. And kita akan dapat final speed dia 40 meter per second. Okay, dah dapat V. Kita substitute balik dalam equation first kita. Okay, so the change of kinetic energy equal to, okay, saya factorize 1 over 2 times dengan mass. Okay, sebab dia sama. So, 2.1 times 10 the power of 3. Okay, tak muat, saya letak bawah. Times dengan V adalah 40 square minus initial kita 15 square. Okay, dan kita akan dapat 1. Okay, kira ya 44 times 10 the power of 6 joule. Okay, jadi dah dapatlah. Dah menjawab kita punya change of kinetic energy. Okay. Kita kena tahu cari Kalau tak, kita tak boleh nak solve untuk soalan nombor 2. Okay, next question B. Dia minta kita cari power of the car. Okay. Power of the car maksudnya the whole process daripada initial to final. Okay. Macam kita nak cari average power lah. Okay, average. Total. Okay, keseluruhan daripada awal sampai akhir. Okay, jadi question yang kedua, nak cari power. Right, and power is equal to work over time or energy over time. Okay, it is the same lah, or energy over dengan time. Since dia minta cari untuk the whole process, okay, untuk the whole process, jadi kita punya energy ini kita akan ambil the change of kinetic energy. Kenapa kita ambil the change of kinetic energy? Sebab ini untuk semua proses. Okay, untuk semua. Macam inilah. Dia macam ini untuk average. Okay, jadi ini pun mesti average. Okay. Average tu macam total lah. Okay, total. Dia semua keseluruhan. Okay, jadi kita substitute saja. 1.44 times 10 to the power of 6 over with 10. Okay, so then kita akan dapat 1.44 times 10 to the power of 5 watt. Okay, kalau takut pening, okay, ini adalah, okay, saya ubah, ini adalah W net. Okay, because as we know, the change of kinetic energy ni adalah equal to net work done. Okay, equal to W net. Oh, tak nampak. Okay, ini adalah W net. Sekejap saya tulis balik. So, ini adalah delta K equal to W net. Okay, dah. Itu je. So, kita kena faham. Power tu nak power macam mana. So, ini power of the car untuk keseluruhan. Jadi, mesti kita ambil untuk the whole process. Daripada initial to final. Okay, dah. Okay, next question is UPS 2007 and 2008. Ni soalan kita. A 650 kg lift starts from rest. It moves upwards for 3.00 seconds with a constant acceleration until it reaches its final speed of 1.74 meter per second. Okay, so then kita lukis diagram dia dulu. Okay, kabelnya ini kita punya lift. And the travel upward, kita cakap upward, and kita identify type of forces that acted on the lift. So, you ada tension and juga weight. Okay, so ada dua type of forces kat situ. Lepas tu kita list out dia punya information. Kita ada mass 650 kilograms. And kita ada U equal to 0 sebab dia start from rest. And our ada T 3.00 second. And ada final speed 1.74 meter per second. Okay. Kita buat boundary sikit. Alright. Jadi kita tengok balik soalan kita. Okay, first question dia minta cari force exerted by the lift motor. Okey, jadi by the leaf motor maksudnya untuk kabel lah. Okey, dia nak cari untuk kabel. Sebab mestilah kabel dia attach dengan motor kan. Okey, untuk rolling benda tu. Okey, jadi soalan yang pertama kita nak cari tension. Okey, and our leaf dia ada relative motion in vertical line. Okey, secara vertical. Jadi kita boleh relate dengan Newton second law. Sebab awak ada change of velocity. Jadi kita akan guna total force equal to MA. Okay, jadi total force kita adalah tension minus dengan weight equal to MA. Okay, kita buat tension minus weight sebab kita refer kepada pergerakan dia. Okay, pergerakan kita, relative motion kita adalah ke atas, upward. And at the same time, tension awak ini pun dia ke atas, dia same direction. So, bila same direction dengan motion, ini kita jadikan dia as the winner. So, winner maksudnya dia adalah positive sign. Okay, and weight is our loser. Okay, so weight ini adalah loser. Ini untuk kita faham ya. Okay, ini loser. Okay, so bila loser dia negatif lah. Okay, dia negatif. Jadi sebab tu tension tambah dengan negatif weight. Okay, jadi T tolak W lah. Okay, jadi kita teruskan. Okay, sebab kita nak cari tension, choose tension sebagai subjek. So ini tension equal to MA plus dengan MG. And saya factorize saya punya mass, acceleration plus with the G. Okay, so kita check all the values. Okay, mass of the leaf given ada. Okay, lepas tu acceleration, oh tak ada. Okay, tak ada. And gravitational acceleration ada, constant. Jadi acceleration A yang tak ada. Jadi bila tak ada kita kena cari. Okay, so tapi macam mana nak cari tu? Okay, nak cari kita gunalah linear equation. Sebab dia involve linear motion kan. Okay, jadi kita gunalah A equal to B minus U over T. So our V adalah 1.74 minus 0 over with 3.00. And kita akan dapat 0.58 meter per second square. Okay, so that's our acceleration. Okay, dah dapat acceleration, baru kita sub in balik dalam first equation kita, iaitu tension. So, tension is equal to mass adalah 650 kilograms multiply with acceleration 0.58 plus with 9.81. Okay, so kita akan dapat 6,753.5 Newton. Okay, jadi dapatlah force exerted by the leaf motor. So inilah jawapan kita. Okay, now kita tengok soalan yang kedua. Okay, soalan yang kedua, dia minta kita determine the instantaneous power in horsepower of the leaf at 3 seconds. Okay, so dia dah bagi specific time, iaitu 3 saat. Jadi itulah instantaneous value. Cuma dia minta kita kira in horsepower. Okay, in horsepower. So bila dia minta in horsepower, dia akan bagi unit conversion of horsepower. Jadi 1 horsepower adalah 746 watt. Okay, jadi tak payah risau-risau, memang dia akan bagi. Okay. Ini kita kira untuk soalan yang kedua. Second Roman. Dia minta cari instantaneous power. Okey, dan kita tahu instantaneous power ni is equal to force times with the velocity cos theta. Okey, dan force kita sekarang ni, sebab kita nak cari force untuk lift. So, siapa yang tengah menggerakkan lift sekarang? Tension. Jadi, force kita adalah tension. So, tension times dengan dia punya V, okay, cos 0 degree. Okay, kenapa dekat sini dia 0 degree? Okay, kenapa dekat sini 0? Sebab dia depends on direction of relative motion dengan tension. Relative motion kita, pergerakan kita ke atas. Okay, ke atas. Dan tension kita pun ke atas. Jadi, dia pada arah yang sama. Okay, macam inilah. Ini dia punya arah acceleration. Dan ini juga adalah arah tension. So, dia occur in the same direction. Jadi, angle kita 0. Alright. Kita substitute lah value dia. So, tension kita adalah 6,753.5 times dengan 1.74. Okay, dan kita akan dapat okay, sila kira ya. Okay, dan kita akan dapat 11,751.09 watt. Okay, ini dalam watt. Soalan bukan nak dalam watt. Soalan minta dalam horsepower. And now, 1 horsepower adalah 746 watt. Jadi, kita akan bahagikan dengan 746 okay, watt, dan ini adalah multiply with 1 horsepower. Okay, ini matematik saja. Okay, so bila kita ratiokan dia, kita bahagikan dia, kita akan dapat 15.75 horsepower. Itulah dia. Jadi inilah instantaneous power pada waktu 3 saat. Okay, sebab dia minta on 3 second. Okay, on 3 second. Jadi pada waktu 3 second itulah kita punya V 1.74. Okay. Itulah dia. Dah senang je. Okay, our last question. UPS 2009-2010. Okay, boleh refer soalan ni juga in Facts Q question number 10. Okay. You are given with a diagram. Okay, dan soalan ni dia bagi. Okay. Soalan ini berbunyi, a 2.6 kg block slides down a rough inclined plane of an angle 20 degrees with the horizontal at a constant speed u 1.5 meter per second as shown in figure 4. Okay, lepas tu kita ada dua soalan. The first question dia minta kita sketch and label the forces acting on the block. Okay, jadi sebelum kita sketch free body diagram yang dia minta tu, okay, kita identify all the type of forces yang acting pada block kita. Sebab block adalah objek kita. Okay, jadi we can see that you punya block has the contact surface with the plane. Okay, jadi bila ada contact surface, of course lah you akan ada normal force. Okay, and our normal force, they always perpendicular with surface. So, surface kita sengit, jadi normal kita sengit macam ni lah. Okay, lepas tu dia cakap ini dia occur on rough inclined plane. Rough ya, yang rough. So bila rough, you akan ada frictional force directed to the right, ke kanan. Kenapa ke kanan? Sebab dia slide ke kiri. Okay. And satu lagi force, kita akan ada weight. Okay, kita akan ada weight. Okay, weight kita ni directed to the earth center. Okay, so itu weight kita. Lepas tu, kita kena tahu our x-axis and y-axis. Okay, first thing kita tengok dulu. Untuk paksi X, dia refer kepada relative motion on surface. Okay, surface kita sengit, so relative motion kita pun sengit. Jadi inilah kita punya paksi X, our x-axis. Okay, x-axis dia always follows you punya relative motion. Dekat mana? Okay, and as we know, x-axis and y-axis are perpendicular to each other. Dia perpendicularly. Okay, dan itulah you punya paksi Y. And kita akan ada angle juga. Okay, sebab dia berada on inclined plane with 20 degrees. Okay, jadi semua orang pun dah tahu inilah angle 20 degrees dia. Dia contact dengan paksi Y. Okay, semua orang tahu saya rasa. Sebab kita dah belajar daripada chapter 4. Alright. Dan soalan kita dah cakap objek kita ni slides down. So bila slides down, tak ada external force. External force ni maksudnya tak ada push or pull force. Tak ada daya tolakan, tak ada daya tarikan. So dia slide sendiri, menggelunsur. Okay. Jadi lepas tu kita keluarkan information yang ada. Okay, first kita ada information iaitu mass 2.6 kilogram. Lepas tu kita ada speed. Okay, kita ada speed. It is 1.5 meter per second. Dan dia cakap ini constant. Okay, ini adalah constant. Jadi bila constant, so kita dapat satu clue which is acceleration kita equal to 0. Alright, so ini sahaja informasi kita ada. Okay. So saya buat dia punya boundary. Kita nak buat dia punya jawapan. Okay. So untuk yang pertama, kita nak sketch the free body diagram. And just now, you had identified all the types of forces. Dah ada. Okay. Jadi ini paksi Y. Kita tegakkan dia. Okay. Supaya mudah untuk kita calculate. Okay. Sebab tu pentingnya awal-awal tadi kita lukis paksi X, paksi Y tu. Okay. Lukis. Jangan degil. Lukis. Okay. Jadi kita nampak normal kita on y-axis. On y-axis. So, kita buat. Alright. And then, you punya frictional force acted on x-axis. So, ini kita punya frictional force. And lepas tu, you punya weight acted pada third quadrant. Sebab tu penting ni kita lukis awal-awal tu. Kita nampak. So, this is our angle 20 degrees. Okay, settle. Free body diagram. Alright. Next question. Okay, question nombor 2. Dia minta kita calculate. Okay, calculate rate of work done by the frictional force. Okay, rate of work done ni adalah okay, rate of work done ni adalah power ya. Okay, sebab rate of work maksudnya work bahagi dengan masa. Itu maksudnya rate of work. So, W over time adalah power. Okay, jadi kita nak cari power lah sekarang ni. Okay, second Roman. Power. Okay, and ini dia nak cari power by friction sahaja. Okay, power by frictional force. Okay, di equation kita gunalah W over with the time. Okay, and kita punya W kita ni, okay, work kita ni adalah equal to F as cos theta. Okay, kita kena ubah ya sebab kita nak cari by friction sahaja. And now kita punya force adalah by friction, jadi saya akan ubah force saya with the frictional force, small f ya, small f ni. Sekejap. Kurang cantik. Okay, frictional force times with displacement cos theta over with the t. Okay, and now kita punya information, dia cakap ini constant speed ya. Bila constant speed, maksudnya 1.5 meter per second ni dia occur dekat setiap masa. Dekat mana-mana pun sama. Okey, jadi based on equation F as cos theta over T, U tak ada T kan? Dan V kita constant. Jadi S over T kita ni, inilah kita ubah dia jadi V. Sebab dia constant. Okey, kita boleh ubah dia. Jadi dia macam instantaneous power. Okey, instantaneous power macam. Okey, sebab dia constant. Jadi bila cari average ke, cari instantaneous ke, dia sama. Dekat masa mana-mana pun sama sahaja. Okey, jadi sebab tu kita boleh jadikan dia adalah frictional force multiply with the V cos theta. Okey, tapi kita ada beberapa masalah. Okey, a few questions sebab sebab kita tak ada value V. Value V ada, value V kita ada. Okay, yang kita tak ada adalah value for frictional force. Okay, value frictional force. And kita kena cari. Okay, macam mana nak cari? Kita akan guna you punya free body diagram. Okay, tapi sebelum tu kita refer balik diagram yang asal. Sebab weight saya sengit. Okay, jadi weight kita maksudnya kita boleh resolve. Okay, so kita resolve. Inilah kita punya W, X dan ini adalah kita punya W, Y. Okay, jadi nak cari frictional force, kita nampak dia hanya involve X axis sahaja. Okay, ini hanya X axis saja. Jadi kita guna summation force on X axis is equal to 0 sebab constant speed. Constant speed dekat situ. Jadi A kita kosong. Okay, A kita kosong. Ni. Kita dah tulis kat sini. A kita kosong. Okay, jadi kita gantikanlah. Ini adalah WX minus with frictional force equal to 0. Jadi frictional force kita adalah equal to mg sin theta. Okay, sin theta ya. Okay, jadi mass U adalah 2.6. Our G is 9.81. And ini adalah sin 20 degrees. Make sure dalam degree mode. Okay, jadi kita akan dapat value of frictional force is equal to, cari ya, 8.72 Newton. Okay, so dah dapat value frictional force, barulah kita substitute balik dalam equation asal. Okay, jadi equation asal kita adalah power by frictional force is equal to 8.72 72. Okay, times with the V. V kita adalah 1.5. Okay, and ini adalah cos 180 degrees. And kita akan dapat 1.5. Kita akan dapat negatif 13.08 watt. Okey, dapatlah jawapan dia. Ni saya nak cerita pasal 180. Okay, kenapa kita ambil angle 180? Sebab arah force kita, arah force kita adalah ke kanan. Arah force U ke kanan. Sekejap saya circlekan arah force kita adalah right. Right. Tapi kita punya motion kita left. Motion kita ke kiri. Jadi dia opposite direction. Opposite direction. Jadi bila opposite direction, angle kita 180. Dan apakah maksud negatif ini? Ini maksudnya, walaupun dia tak minta, saya cakap saja. Ini sebenarnya power loss by frictional force. By friction. Ini untuk kita faham saja. Itu saja untuk chapter 5, work, energy and power. Jumpa lagi di masa akan datang. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Sudah sesi kita pada kali ini. Semoga pelajar semua mendapat manfaat dan lebih faham tentang chapter ini berdasarkan pembincangan yang telah kita adakan sebentar tadi. Jangan lupa seperti saya beritahu di awal sesi kita tadi, isikan borang kehadiran yang linknya akan diberikan selepas ini. Semoga kita akan bertemu lagi pada sesi yang akan datang. Assalamualaikum.